Okay, so this is chapter 9, problem number 2 for exam 3 for bonus questions. And this question is asking us the Henry's law constant for CO2 is 3.4 times 10 to the negative 2 molarity per atmosphere at 25 degrees Celsius. Assuming ideal solution behavior, what pressure of CO2 is needed to maintain a CO2 concentration of 0.1 molarity in a can of lemon lime soda? So what we need to do is we need to figure out which equation we're going to use here. So if we recall, we can use the solubility of gas equation, which states that, which the formula is the solubility of gas is equal to Henry's law constant multiplied by the pressure of said gas. So this is the equation we're going to use in this example here. What we need to figure out though is obviously what are we missing? Now obviously we've got Henry's law constant, because if we look here, that's the 3.4 times 10 to the negative 2. So we have this. So what we can say here is that K gas, which again, that's Henry's law constant, we're going to let that equal 3.4 times 10 to the negative 2. Now this is going to be, again, molarity per atmosphere, or we can also call this moles per liter times atmosphere. Okay, so then, or moles per liter over, with atmosphere, the denominator. So now, what else do we have here? So we also have a concentration of 0.1 molarity. Well, we've got two different variables left. Obviously, we've got the pressure of gas. Now, pressure of gas is measured in ATM. It's not measured in molarity. Now, solubility, or we can also call it concentration, that is going to be measured in molarity. So we can say that the solubility of gas, is going to equal the 0.1 molarity. So we can say that S gas is equal to 0.10 molarity. So we've got two terms. We've got a missing piece. So what I can do is I can solve for the pressure of gas. Now, how do I do that? I do it by dividing by the Henry's law constant. So I'm going to bring this over by dividing it on both sides. So in doing so, I'm going to get the pressure of gas is equal to the solubility of the gas divided by Henry's law constant of that gas. Now let's go ahead, and the gas in question here is obviously going to be CO2. So I'll change that to CO2. Okay, now let's go ahead and plug in what we have. So we don't know what the pressure is. That's what we're solving for. But we do have a 0.10 molarity, and I'm going to also call that moles per liter. And then down below, I'm going to have my Henry's law constant of 3.4 times 10 to the negative 2 moles per liter atmosphere. Okay, so what we've noticed here is that we have moles per liters get canceled, which is great. So we've got everything in just terms of atmosphere. However, let's go ahead and look at this a little closely. So the partial pressure, the pressure of carbon dioxide, CO2, is going to equal 0.10 over 3.4 times 10 to the negative 2. Now this 1 over atmospheres, the atmospheres can come up. So because this turns into 1 over atmosphere, and when we're dividing by a fraction, we can just multiply by its reciprocal. So that means I'm going to have the atmospheres up top. So now all we have to do now is just check this calculation, figure out what this pressure is going to be. Notice that 10 to the negative 2 can basically come up as well. So I could necessarily, I could say that the PCO2 is going to equal 0.10 times 3.4 times 10 squared ATM. Now, why did I do that? Because I have 10 to the negative 2 down below. So whenever I have this negative exponent, you can bring it up to the opposite side of the fraction. So let's just find out real quick what this calculation is going to be, and then we'll have our final answer. So I get a final answer. So my pressure of the CO2 to maintain a concentration of 0.10 molarity needs to equal 2.94 atmospheres. So this is going to be the final answer.